So in the last class of COA of BCA third semester, we simplified some Boolean expressions. So today we shall study the digital combinational logic circuits. Okay, so before studying this, we shall study the concept of digital combinational logic circuit. So you know the meaning of digital, right? Digital is nothing but digital device which generates, processes and stores the data in the form of 1 and 0. That is nothing but what? Digital. Example, smartphone and smartwatches. Next, logic circuit. You know about the logic circuit, right? Which operates or performs the operation only on the binary inputs, that is 0 and 1, and gives the result as 0 and 1. Then what is this combination? See, in the digital logic circuits, there are two types. So in the digital logic circuits, there are two types of circuits. One is combinational, another one is sequential. So what is the meaning of combinational? Combinational digital logic circuit is a digital logic circuit in which the output depends only on the present status of the input. That is nothing but combinational circuit. Whereas a sequential means, as the name indicates, sequence means one by one. So sequential is nothing but it is a digital logic circuit in which the output does not depend only on the present status but also on the previous status of the inputs. So the example for this is logic gate. As we have studied logic gates in the first class. So logic gate means what? You take any logic gate. For example, AND gate. If you take AND gate. So here this is the output, right? And these two are the inputs. So here this output is depending only on the present status of the input, not on the previous. That's why the logic gate is an example for the combinational logic circuit. Whereas sequential best example is flip-flop. So what is this flip-flop actually? So this flip-flop is a circuit which can store only one bit at a time. Okay. So here if we consider the output is not only depending on the present status of the input but also on the previous status of the input. So this flip-flop we will study in the upcoming classes because we have so many flip-flops like D flip-flop, T flip-flop, SR flip-flop and J flip-flop. Okay. So all these flip-flops, that is sequential circuits, we will study in the next class. So as of now, today we will study only about the combinational logic circuits. So now, in this, we shall study adder circuits today. Adder circuits. So as the name indicates, adder means what? It is a circuit which is adding. What it is adding? It is adding binary numbers. Okay. So in the adders, again there are two types. One is in the adder circuits there are two types. One is half adder and another one is full adder. So what is this adder actually? Adder is a digital combinational logic circuit which adds the binary inputs and gives the binary output. Okay, so in that we shall study the first one, that is half adder. So what is half adder? So half adder. So what is this half adder? Let us draw the symbol. as block diagram. Okay. So this is what the block diagram of the half adder circuit. So as the name indicates, this half adder is a digital combinational logic circuit which adds two binary inputs and gives two binary outputs, namely carry and sum. Here C stands for carry and S stands for sum. Okay, so this is about the block diagram. Then logical expressions. So the logical expressions are carry is AB and sum is A XOR B. So AB is nothing but which gate it is? AND gate. A XOR B is nothing but XOR gate. Now we shall write the truth table for this. See, now as usual we are having two inputs, that is A and B, and two outputs, carry and sum. See, there are two methods to remember the output. So one method is nothing but the gate, AND gate. So we already know what is AND gate. When both the inputs are true, then only it is true. Okay, otherwise it is 0. So carry is over. Next is sum. That is nothing but XOR gate. What is XOR gate? When both the inputs are same, then the output is 0. So this is 0, then the remaining are 1. So this is one method to remember the truth table. There is one more method. So one more method is nothing but adding both the inputs and writing the output as 2 bits. Okay, see, it is adder, so add both the inputs. 0 plus 0, that is 0. So how do you write 0 in 2-bit combination? That is 0, 0. Hence it is 0, 0. Next, 0 plus 1 is nothing but 1. How do you write 1 in 2-bit combination? That is 0, 1. So 0, 1. Next, 1 plus 0 is also 1. How do you write 1 in 2-bit combination? 0, 1. Next, 1 plus 1 is nothing but 2. How do you write 2 in 2-bit combination? That is 1, 0, hence it is 1, 0. See, this is also the same thing, and XOR. So this is how there are two methods to remember the truth table. Okay. Now, based on the logical expression, we have to draw the logic diagram. See how to draw the logic diagram. Let us take A and B as inputs. The carry output is nothing but A into B, which is nothing but AND gate. So we shall take AND gate here. So this is nothing but the output carry, which is equal to A into B. Next, sum, that is A XOR B. So let us take the same lines here, that is input. Okay, so put XOR gate. So this is the sum. Sum is equal to A XOR B. Okay, so this is the logic diagram of half adder. So what is half adder? Half adder is a digital combinational logic circuit which adds two binary inputs and gives two binary outputs, namely carry and sum. Okay, and these are the related information about half adder. Now let us study the next one, that is full adder. means what? See, the only difference between half adder and full adder is you can observe in the block diagram. There in the full half adder, it was having 2 inputs and 2 outputs, and here only thing is it is having 3 inputs and 2 outputs as it is. So how to define it? Full adder is a digital combinational logic circuit which is having 3 inputs and 2 outputs, namely carry and sum. So here it is going to add 3 binary inputs instead of 2. So therefore, now let us write the truth table for this. And see, if you observe this, here instead of C I have written CO, nothing but carry output carry, because there are 2 C characters here. Okay. Now, here we have to write 3-bit combination input. 0, 0, 0, 1. See, one easy way to remember this 3-bit binary combination I tell you. So as it is 3-bit binary combination, we are getting 8 sequence. How to write 8 sequence? The first one will be 4041. That is 4 zeros, then 4 ones. Next, 2 zeros, 2 ones. So 2 zeros, 2 ones. Alternately. Next, C is 0101 alternately. So this is the best way to remember 3-bit binary combination. Okay. Now, as usual, here we just have to add all the 3 bits, and we are supposed to write the result as a 2-bit binary combination. So 0 plus 0 plus 0, nothing but 0. How do you write 0 in 2-bit? 0, 0. So write 0, 0. Next, 0 plus 0 plus 1 is nothing but 1. How do you write 1? That is 0, 1. So write down 0. Next, 0 plus 1 plus 0, again 1. So 0, 1. Next, 0 plus 1 plus 1 is nothing but 2. How do you write 2 in 2-bit binary combination? That is 1, 0. Therefore, it is 1, 0. Next, 1 plus 0 plus 0, 1. So 0, 1. 1 plus 0 plus 1, 2, 1, 0. 1 plus 1 plus 0, 2, 1, 0. 1 plus 1 plus 1, 3. 3 is nothing but 1, 1. So it is 1, 1. Okay. So this is about the truth table of the full adder. Coming to the logic diagram. Okay, before going to the logic diagram, we must be knowing the logical expression, right? So, logical expression. Logical expression for this. See here, why the expression is like this, that we can simplify here. See, let us write CO, that is carry. So, wherever the carry output is 1, we have to write the corresponding expression of the inputs. See, here it is 1, and what is this? BC. Leave this 0. Okay, only consider the true value. So it is BC. So it is BC plus. Next, when it is 1, see here AC. So it is AC. Next, when it is 1, Okay. So next it is AB. So it is AB. Okay. And this is nothing but ABC. So we have to consider 1, 2 and 3. Therefore it is, so we can rearrange and write it as AB plus BC plus CA. So this is the output of the carry. Now consider sum. So what is sum here? Where it is 1. So this time you consider all the variables. So A bar, B bar, C. A bar, B bar, C plus next A bar, B, C bar. A bar, B, C bar. Okay. Next A, B bar, C bar. Next, the last one, that is A, B, C. Okay. Now we have to simplify this in order to get our output. What is output actually, which I wrote before? That is A XOR B XOR C. Okay. So now, are they common here? A bar, only A bar is common. So let us take A bar. What is left here? B bar C plus here B C bar. Okay. Next, which is common here? Only A is common here. So take A. Here is B bar C bar and here is B C. Okay. So now, what is this B bar C plus B C bar? We have studied XOR, right? So what is XOR, which I told you? A XOR B is nothing but A bar B plus A B bar. So apply this here, then this will be B XOR C. Therefore, A bar into B XOR C. Correct? Now, this one, A into, what is this B bar C bar plus BC? Nothing but XOR. So what is XOR expression? A XOR B whole bar is equal to AB plus A bar B bar. Okay. Therefore, this is nothing but B XOR C. So B XOR C. Okay. Now, let B XOR C is equal to X. Let us take B XOR C as X. Now replace this A bar into X plus A into, what is this will be? B XOR C is X, then B XOR C complement will be X complement. Okay. So now, this is A bar X plus A X bar. Okay. So now, what is this A bar X plus A X bar means? Again apply the XOR gate here. So this is nothing but A XOR X. Okay. Now I write the value of X, the expression for the X. What is X here? B XOR C. Therefore it is A XOR B XOR C, which is nothing but our sum expression. So this is how we get the expression for the sum output. Okay. So this is about full adder. So if the question is asked like explain full adder, you need to draw the block diagram, you need to define the full adder, then you need to write the truth table properly. And remember one thing, while writing the truth table, you have to keep in mind that you have to write carry first and sum next. If you reverse this, it will be totally wrong. Next, you are supposed to draw the logic diagram now. Now the last one is logic diagram for this. Okay, so what will be the logic diagram here? Take three inputs A, B, C. Now let us take AB first. So this is AB. Okay, so this is AB and gate. Next BC. Take B, then take C, put AND gate. So this is AB and this is BC, and one more is CA. Take C and take A. This is CA. So now we have to add these three using plus. Plus is nothing but OR gate. So let us add these two first. Put OR gate. This is addition of both the inputs, AB plus BC. Okay. Now take this and add with CA. So this is nothing but the addition of these two lines, that is AB plus BC plus CA, which is nothing but a carry output. So this is the logic diagram of carry output. Now sum A, B. So A XOR B. Let us take A XOR B first. Put XOR gate. This is A XOR B. Now take C line here. Take these two. So put XOR here. So this is XOR of these two inputs. This is C. Therefore it is A XOR B XOR C, which is nothing but sum. So this is about the logic diagram of the full adder. So we shall stop here. In the next class, we'll solve the K maps. Okay, thank you.